Okay, welcome back everybody. We are getting ready for the Chapter 5 test on linear and quadratic functions. And I'm going to do some practice problems with you. You can just get a blank Notability doc out. I would strongly recommend having your graphing calculator out. They are going to be strongly recommended for the test tomorrow, so bring it with you. And here we go. So to start with, I'd like to just talk about an absolute value. I'd like you to solve this absolute value. So let's give it a pause and see how you do. Okay, let's see if you split this puppy up into two parts. 6x minus 3 is equal to 5, and 6x minus 3 is equal to negative 5. And then we're going to add 3 to both sides, and we have 6x equals 8. Add 3, and 6x equals negative 2. And divide both sides by 6. And you have x equals, let's reduce 8/6 to 4/3. And let's simplify this, 2/6 to 1/3. Negative 1/3 to be exact. Yay, I got my two answers. Now, if my grade depended on it, I might go and check and make sure, like for example, if I were to put it 4/3 right here, would it really come out to 5? All right, well, let's put this as a 6/1. That's going to make it 24/3, because 6 times 4 is 24, and 3 times 1 is 3, so 24/3, that'd be 8. 8 minus 3 is 5. Cool, it worked. I think you get the idea. Now, what if this had been a less than or equal to 5? Then I go down and make a graph. I want you to think when you see one of those that it kind of looks like the tip of a number line, because then the answer is a range of values. Here's negative 1/3. Here is 4/3. Empty circles, but since it's or equal to, I fill them in, and I can decide whether or not they're, I know, I taught you a different way where you could go through and say this is less than, this is less than, this is less than, and then it switches to greater than and greater than and greater than or equal. You can do it that way, but I also want to talk about testing intervals. So to test the intervals and see where it worked, I'm going to test the number 0. So I'm going to go back up and put a 0 into my equation. That'll give me 6 times 0 is 0, minus 3 is negative 3. Absolute value of that is 3. Is 3 really less than or equal to 5? It is. So it worked in there. And that testing intervals is important because on quadratics, you can't know which way to shade. I mean, you can, actually, there's other ways, but we don't just bring the signs down throughout a quadratic. So again, usually you either shade in between or you shade on the outsides like this. So let's do one like that with a quadratic. Let's say we had x squared plus 3x minus 4, and we'll ask where that's greater than 0. All right, everybody, give that one a shot. And remember, once you make your number line, you're going to be testing the intervals around the roots. Okay, let's see if you did it the same way that I would. I would factor it, because if you can factor it, you should. Now, this is an important point. What if it hadn't factored? What if this just wouldn't factor? Well, then you would use the quadratic formula. And the quadratic formula would work. It gets you the roots every single time. Factoring doesn't work every time. When it does, it gives you nice, easy answers. X equals negative 4 and x equals 1. And those are much easier than the quadratic formula, which has 16 parts to it. So, all right, now, just double checking myself that I factored it right. Looks like I did. If I were to take these two and put them on a number line, The negative would be on the left and the positive would be on the right. I'd put an empty circle around them. Am I going to fill in the circle? I hope you knew the answer was no, because this does not have an or equal to symbol. It's got just a greater than symbol. Now, I'm going to test this interval here. I'm going to put in a 2 and see if this area right here, between here and here, if that area works. Now, I could put it in the original, but I find it's a little easier to put in the 2 up in here in the factored form. And remember this part where I could just find out if it's positive or negative? This is positive 6 in this zone here. In this zone, it's positive 1, but it's really a positive times a positive, which is a positive, which will be bigger than 0. So, hey, it worked out there. So I shaded in. And now I could test a number. I suspect that it's going to work over here then also, so like -5. But remember me saying that you could test a number like -50? Because if you just care if it's positive or negative, this one would come out negative, this one would come out negative, and a negative times a negative is a positive, which is bigger than 0. So it'd work. You don't have to get the exact answers. If you really want to, you can, if you like that way better. Okay, now I'm obviously not shading in the middle. Now, I'd like to just make you think of about one more thing on this. You don't have to do it this way, but some kids are going to like it. Here's a parabola. It would have gone through those roots, right? If I graphed this, it would have gone through 1 and -4, because, the zeros are the same thing as the x-intercepts. And then it's like, where is the parabola bigger than 0? Well, in this area and in this area, the parabola would be above 0. So that'd be another way to decide where to shade. Okay, so there's a couple good practice problems. Let's do another one where we do a regression, a linear regression. Okay, so I'm going to give you some data that you can use to put into your calculator. So at this point, grab a calculator, and if the teacher needs to pause the video for a second to make sure everybody's got a calculator, maybe some people need to borrow one. I need them back, of course, if you do borrow them. And we're going to put in this data on our L1 and your L2. We're going to put in the data of 1999, and there were 15. Let's say this is like how many malls there were in Minnesota. In the year 2000, it was up to 20. In the year 2001, it was up to 25. And this is our X, our year. This is our Y. In this case, how many malls there were in the state. And now, what can you do with that? Well, you can do a linear regression. So go to your graphing calculator and hit the Stat button. And under Stat, you're looking for Edit. And under Edit, when you hit Enter, you will see an L1 and an L2 list where you can enter the data just like I just told you right here. The DEL key is the best one to delete out old data that might be in there. Then once you've got that all entered, you are going to hit the Stat button again, and you're going to arrow over to the Calculate tab on the Stat menu and arrow down to the fourth one, which is Lin Reg, which stands for linear regression. Then, depending on the style of calculator that you have, you might have to hit enter a few times. You'll end up getting a linear regression equation, which would be in this case y equals ax plus b, where a is 5 and b is negative 9980. Now I'm going to give you the follow-up question. So if we have had you figure out that this equation is the answer, then what do you do with it? Well, you can predict. So let's say I said if we were going to continue at that same pace, our x was our year, remember? Okay, so if I tell you that the year is 2015 now, how many moles would there be? Let's see if you can figure that out. Okay, so you should have put the 2015 in right there, and you'd have y equals 5 times 2015 minus 9980, and you should have come up with 95. Now, if instead they'd have given you 95 moles and they had said, hey, when is there going to be 95 moles? You would have put the 95 right here, and you would have solved this equation for x, and it would have said 215. Okay, so there's an example of how to do linear regressions. Okay, next, let's talk about finding linear stuff, linear equations. So if I give you an equation like this, and I have the point 2, 5 on that line, and I tell you that I want a slope of, see how it's not rising very much and it's running a lot? Let's say it's rising 1 and running 3. Would you be able to tell me the equation for that line? I'm going to pause for a second while you give that a try. Okay, let's see if you knew how to do that. This is a point. This fundamentally was my rise and my run, and so I gave you a slope, really. And so I hope you knew this equation. Y minus y sub 1 is equal to m times x minus x sub 1. You need to memorize that one. And the slope here was rise over run is 1/3. Our point was 2 and 5. X is 2 and y is 5. So I got y minus 5 is equal to 1/3 x minus 2. And from there, that's good enough, first of all. That is an equation that has the slope we wanted and the point that we had. But I want to just take it a little further. A lot of people would want you to solve this for y, because the cool part is then you have your equation in vertex form. This seems kind of weird. It's like the point 2, 5 has a slope of 1/3. Now I know a lot of you don't think of that as vertex form, but it kind of is. Now if I multiply that out, it'd be 1/3 x, and then I multiply negative 2 times the 1/3 we're distributing here, and we get negative 2/3 plus 5. If I simplify that down, it'd be y equals 1/3 x, and 5 minus a 2/3 would be 4 and 1/3. If you'd like that to be a improper, it would be 13/3. Okay, so there's another good equation, but this one was just as good. This blue one up here, that one was fine. But this one's in slope-intercept form, and this one is in point-slope form. Now what if I said I wanted to have a line that was perpendicular to this one? Well, then I hope you'd know to not keep the slope the same. If you kept the slope the same, they would be parallel. But if it's perpendicular, you'd flip it and make it negative. And now I'd say x, and then if I just want a line that's perpendicular, I can say any y-intercept. Like I'd say plus 10, whatever. And that would be perpendicular to that. All right, let's talk a little bit more about that quadratic stuff. I'm sure a lot of you left yesterday shaking your head about that. Oh, that quadratic stuff is scary. It's mostly just because there's a lot of stuff to grind out. Okay, so imagine you've got your quadratic and you've tossed a ball in the air and you started at 2 meters high. That'd be a lot like the lab. And let's say that we didn't know the peak, but we knew that we had thrown it with a velocity of 20 meters per second. Could you write the equation for that? Let's just start with that. What's the equation? And it starts at 2. We're on planet Earth using meters, and we have a velocity of 20. See if you can write the right equation for that. Okay, so you should have said that you start with y equals, you could say f of x, of course, negative 4.9, and you could use t or x, and it's squared. These are quadratics, of course. And then the velocity of 20 gives you plus 20x, and then it started at a height of 2, the initial height, so I put a plus 2 there. Cool. Now, if I tell you an x, then you should be able to tell me the y. So I'm going to say, let's say x equals, let's say 1.5 seconds. All right, so at 1.5 seconds, you put that into your calculator. And when I stuck that into the equation and into my calculator, I got 20.97. That would actually probably round to 21. We would tell you on a test where to round to. So, and what is y? The number of yams? No. Y is this, which is the height. So my parabola would have a height at that moment of 21 meters. All right, it started at 2. So is 21 the very peak? No. We don't even know for sure if it ever went higher than that. It could have been the peak. It's likely, though, unlikely that we guessed exactly the moment that we got the vertex. So that's what I want you to figure out next, is where would the vertex be? Hint, you need to know another formula to be able to do this. Okay, so hopefully you remembered that this is the x of the vertex, and that would be negative b over 2a, which in this case is negative 20 over 2 times negative 4.9, so negative 20 over negative 9.8. When you divide those two, you get 2.04. All right, so that's going to round to 2 seconds. At 2 seconds, we have found our vertex. Now, how high would it go? That's a whole different question. Let's save you some time. Just say, if you wanted to know how high it went, you would put it into your original equation here, and then put the 2 seconds right there and right there, and then you'd solve for y, and you'd have y, your height, at that exact moment. All right, what if another question came up and they said, I want to know what time it was at 4 meters. Let's say it's that spot right there. Well, if you do that, you're going to actually have 2 times that it hits 4 meters, because here's where 4 meters is, and here's where 4 meters is. You draw that line across there, and you're at height of 4. Now, where do you put it? This is where height goes. So you'd put a 4 right there. And then remember, quadratics have to be set equal to 0. So you'd subtract 4 from both sides. And now you've got a new quadratic to solve. The quadratic formula would save the day there. All right. Enough about that kind. Let's talk about, what if we had a really complicated looking equation? And normally, you know, they're ax squared plus bx plus c. That's what your quadratics look like. What if I decided to change it to mx squared plus rx plus y equals 0? Could you do that? Yes, I could. And I just said that your starting height is y, your velocity is r, and your a term, which is like the gravity, that would be m. All right, so all kinds of variables all over the place. We do this in pre-calc because we try to see, can you handle it when the numbers are variables instead of numbers? So if I had just a second ago, I asked you for the vertex, and you guys knew to do x equals negative b over 2a. The answer for this one, you can find me the vertex for this. I'm going to pause for a second while you find me the vertex for this. Hint, you don't have to simplify it all the way. Let's just get the x of the vertex. All right, so negative b over 2a is great, but in this case, it's negative r over 2m. Is that it? Yes, that is the x value of the vertex. Negative r over 2m. So what's the rest of the vertex? I'll pause for a second while you figure out the rest of the vertex. Okay, so what you would do is f of negative r over 2m. Now, I respect it if some of you guys actually took this equation and then stuck negative r over 2m in the x spot, because you're sticking it into the equation. Negative r over 2m, go here and here. And then if you did that, you'd be able to solve it down and your answer would have a y in it, but that gets really complicated. What I was really looking for was just that. Okay. Given this, again, this red equation, I'll rewrite it up here. If I said mx squared plus rx plus y equals 0, what if I asked, what was the starting height? Don't say c. The starting height was y. That was the initial height. What if I said, what was the velocity in this case? And you wouldn't say b, and you wouldn't say v, because of the way we wrote this equation. You would say the velocity was r. Okay, I think that's enough on that type of question. So I know that the inequalities that you have to handle can be intense when they are factorable. So let's say it's x squared plus 5x minus 6 is greater than 0. Well, that can be factored, and so that should help you a lot with how to get the answer. Let's everybody give that one a shot. All right, if you can factor it, you should. You should have said this was x, and then, let me think, I think it's plus 6 and x minus 1, double checking that by multiplying on the outside and the inside, and I get positive 6x and negative 1x makes positive 5x. Yay, it worked. And then I know that I need one of these because that looks like the tip of a number line. And then I know that I have negative 6 as one of my key points, and so is 1. And I circle them, and then I say I don't fill them in because I don't have an or equal to. Next, I don't know if you remember me doing this last time, but I'm just sketching. This would be a parabola that would have those two x-intercepts, and I'm asking when's it bigger than 0. I can tell right now that it's going to be here because that's where the parabola is above 0, and here. And if that's not working for you, then let's test intervals. Let me give you a minute, everybody. Give this one a try. How would you test an interval here? Okay, so you should have said, I'm going to test 2. You go back and you put 2 in here and here. Now I have 8 times 1 is 8. 8 is bigger than 0, so it worked. Yay, I shade out here. And then again, you'd shade here. I can prove to you this doesn't work by putting in a 0. I could even put that in the original equation and show you that negative 6 is greater than 0. No, it's not. So those numbers in here don't work. All right, so your final answer could be written, if you wanted interval notation, maybe the test says must be an interval notation, you'd say negative 6, and then you'd put a, let me think, does it actually work at negative 6? It was an empty circle there, so it doesn't work at negative 6, and it was a empty circle at 1, and then to infinity, union symbol. There we go. That's when this quadratic would have answers that are bigger than 0. All right, one last thought. I give you a quadratic, x squared plus nx Notice, normally, that's b, plus 4. And if I set this quadratic equal to 0, no, actually, let's have it equal y. If I make y equal to 0, I'm finding the x-intercepts, but I'd like to set equal to y. Let's say I said I wanted to have 2, and actually let's have no solutions. Let's say there are no solutions. How can you tell what n would have to be? This comes down to the discriminant, b squared minus 4ac. Do you remember that? It's part of the quadratic formula, x equals negative b plus or minus the square root of all over 2a. And this part here, if this part is less than 0, then there would be no solutions. So you'd want to set up b squared minus 4ac needs to be less than 0. But what adds that in this case? I'm going to put in b is n. See, that's our b in this case. So n squared minus 4 times a. I know the a. A is a 1. There's a 1 right there. 4 times 1 times, I know the c is a 4 right there, is less than 0. And now I have n squared minus 16 is less than 0. And does that look familiar? N plus 4 and minus 4 less than 0. Draw a line, and I get negative 4 and positive 4, empty circles. And then I'm going to say I want to test intervals. Let's say I test 0 in here and see if it works. I'm going to put it in this equation. 0 minus 16 is negative 16 is less than 0. It worked, and I'm pretty sure it's only here. Now I'm going to test it with this other way. It's a parabola that's right side up because there's no negative in front, so it's a parabola. And I wanted to know when the parabola was less than 0. Well, during this whole time is when the parabola is less than 0, so it worked. Negative 4 to 4. And there's no or equal to sign, so it's parentheses, and there you go. Final answer from negative 4 to 4. Okay, now the Schoology quiz for last night I think might have been tough for some of you, and I think, of course, I'm leaving some challenge left on the test. I didn't tell you how to do everything. You have to be able to figure it out. I've given you all the tools that you would need to be able to ace that test. Now let's see if you can do it. So I would recommend that Schoology quiz, maybe do it another time, and that's one of your best places to get practice problems. Otherwise, any of the problems from the homework assignments are nice because the answer keys are posted. So any old homework assignment, you could go back, find a few problems of the kind you know you're weak on, and work on those. All right, that's all I have for you for today. I hope you rock that test tomorrow on Wednesday.